Morning students. As you know that today we are going to discuss part 7 of our unit second, that is units and measurement. And before this we had discussed the topics that are measurement of mass, different types of masses which came into picture, that is inertial mass, measurement of inertial mass, measurement of gravitational mass, units of practical units of masses, range of masses in kilogram. In range of masses in kilogram, we had discussed from the mass of the universe, that is 10 to the power 53 kg, to the mass of the electron, that is the smallest mass, 10 to the power minus 30 kg, and the ratio of these masses we had got 10 to the power 83. Now today we will discuss range dependent mass measuring techniques. Means how the mass measuring techniques work, what are the different mass measuring techniques which are dependent on range. So let us understand this. The first one is for measuring ordinary masses. For measuring ordinary masses, ordinary masses for measuring ordinary masses means to say that, just say we can say that 5 kilogram of flour, 5 kg of wheat, these are ordinary masses. Ordinary masses means that masses which we are facing in our day-to-day life, that are ordinary masses. So what are the measuring techniques? The physical balance or common balance, or you can say that, okay, for the measurement of these masses we compare it with a standard mass by the help of the balance. Compare with standard masses by help of balance. Second one is to measure heavy mass. For measuring the mass of a heavy body like vehicles, mass of heavy vehicle, mass of heavy vehicle, mass of heavy vehicle. Mass of heavy vehicle can be measured by the weighing machine, weighing balance, weighing balance oblique weighing machine, weighing machine. By the help of weighing machine or weighing balance we can measure heavy masses. Now for the measurement of bigger masses like mass of the earth, mass of the universe, some indirect methods. These are the direct methods. Direct methods means what? Direct methods are that methods in which we compare the given physical quantity with some standard quantity and read out the value. That is called the direct method of measurement. Now we can't employ the direct method of measurement for measuring very bigger bodies, very bigger masses. So for measuring bigger masses, for measuring bigger for measuring bigger masses, indirect methods are used. Indirect methods are used. Now, in this context, I am discussing one of the indirect method, that is measurement of mass. So as you know that in that g is equal to small g is equal to gm upon capital R square, and from here we can say that a small m is equal to a small g R square upon capital G. Clear? So here you are seeing that what you are observing, this is the mass of the earth. You had studied already, you had studied in the previous class, in ninth class, about this formula. This formula is the acceleration due to gravity, and this acceleration due to gravity is directly proportional to the mass of the earth and its radius. And here the acceleration due to gravity on the surface of the earth is generally a fixed value. R is the radius of the earth and G is the universal law of gravitation, which had been already calculated. So by putting these values in this equation, we can get the mass of the earth. Capital M is what? Capital M is equal to mass of earth. Capital R is equal to its radius. Small g is equal to acceleration due to gravity, and capital G is equal to universal gravitational constant. Universal gravitational constant. Now I am writing each and value of mass of the earth. So a small g, as you are knowing that 9.8 meter per second square. Acceleration due to gravity, that is universal gravitational constant, 6.67 into 10 to the power minus 11 Newton meter square per kg square. This is, and putting these values, small g and the value of R, that is equal to 6.4 into 10 to the power 6 meter. So putting these values, R, small g, R, this is R, this is 9.8, and this value in this equation, putting these values, so g is equal to 9.8 meter per second square into R square. R is 6.9 into 10 to the power 6 meter whole square, and upon G 6.67 into 10 to the power minus 11 Newton meter square per kg square. From putting these values and after calculating, we get the value of M. We get the value of capital M, and the value of capital M is equal to 6 into 10 to the power 24 kg. 6 into 10 to the power 24 kg. So by using this indirect method, you can calculate the mass of the earth. This is the indirect method for the measurement of the mass. Now we will come across the measurement technique for very small mass like atomic mass. Measurement of atomic mass. Atomic mass and nuclear mass. Atomic masses and nuclear masses can be measured by the technique that is called mass spectrometer. Mass spectro mass spectrometer. Mass spectrometer. This is a technique, mass spectrometer. Mass spectrometer is a device by the help of which we can calculate or we can find out the measurement of atomic or nuclear masses. It is something we do. I want to make here quite clear that the direct method gives the accurate value, but by the help of indirect method we are not going to get the exact or accurate value. We are going to get the approximate value or estimated value. So by this method, mass spectrometer, it is a technique used for the measurement of atomic masses, and here the light is used as spectrometer. Something like a spectrum is observed, and by the help of that spectrum, mass of the object can be estimated or determined. Now the last one is mass of an electron. Mass of electron. Mass of electron. Mass of electron can be measured by the Millikan's wire drop experiment, and we have calculated it as 1 E upon m is equal to, further we will calculate 19 coulomb per kg. 1.7 into 10 to the power 11 coulomb per kg, and charge on the electron we are knowing 1.6 into 10 to the power minus 19 kilogram. Charge on the electron 10 to the power minus 19 coulomb. Now mass can be written as E upon m, and from here we can write it as 1.6 into 10 to the power minus 19 coulomb upon 1.7 into 10 to the power 11 coulomb per kg, and from here we can get 9.1 into 10 to the power minus 31 kg. This is the mass of electron. This is the mass of electron, 9.1 into 10 to the power minus 31 kg. Nine point one into 10 to the power minus 31 kg. By Millikan's wire drop experiment, we had calculated. This is also the indirect method. This is not the direct method. Indirect method. Indirect method. In this method, we had calculated the EM upon m ratio of the mass of by Millikan's wire drop experiment, and we had calculated the charge of electron, and E upon m ratio gives the mass of electron, that is 9.1 into 10 to the power minus 31 kg. So students, this is all about the measurement of mass, the different ranges of mass, the different mass measuring techniques for different range of masses. Now we are going to discuss the next important physical quantity, measurement of the next important physical quantity, that is measurement of length. Next one is measurement of length. Measurement of length. Measurement of length. Length is also a very important physical quantity, and first of all I want to define here what is length. So length is the distance between 2 points, separation between 2 points in a space. Length is nothing, separation between 2 points in a space. Suppose there are 2 points marked in the space, and what is the distance between these 2 points is the shortest distance, or the shortest distance or shortest separation between these 2 points is called as the length between these 2 points, and that is called length. Here also there are two, as in case of mass, measurement of mass, we have discussed about two methods of measurement of mass. First one is the measurement of mass. First one is the direct method of measurement of mass, and second one is the indirect method of measurement of mass. In a similar way, measurement or separation between 2 points in a space can be measured in two different techniques. First one is direct method, and second one is indirect method. So the direct method, as I had told you earlier, that in case of direct method, the physical quantities can be measured by only by the help of the instrument, and the direct method is the accurate value, or gives the accurate value of the measured quantity, accurate value of the measured quantity. But in indirect method, we are getting, or we get only approximate value or estimated value of the measured quantity. So first one is direct method. First we will discuss about direct method. Direct method. Direct method for the measurement of length. And the direct method in measurement of length, the shorter distances, the smaller distances can be measured. That distance, that lengths which we have the use in our day-to-day life, means the length of 2 points drawn on the paper, distance or length between 2 points drawn on the paper, or the thickness of a wire, or the diameter or gauge of a wire, the depth of a beaker. All these things we need in our daily use or daily experiments. So these things can be measured by the help of direct method. So what instruments are used for direct method? Meter scale, meter scale for distances from 10 to the power minus 3 meter to 10 to the power 2 meter. Second one is vernier caliper. If the distance is 10 to the power minus 3 meter to 10 to the power 100 meter to 0.001 meter, this distance, the 1 millimeter to 100 centimeter, 1 millimeter to 100 centimeter, that distance can be measured by the help of meter scale. Now vernier scale, less than 1 millimeter, distance less than 1 millimeter, that is vernier caliper. You students, you are going to observe this vernier caliper and know about its uses in your physics laboratory, physics lab. Vernier caliper for distance up to 10 to the power minus 4 meter, means the distance which is of the range of 10 to the power minus 3 meter to 10 to the power minus 4 meter can be measured by the help of vernier calipers. And the next one is screw gauge. Next one is screw gauge. Screw gauge. Screw gauge. The screw gauge and spherometer, screw gauge and a spherometer is used for distance up to 10 to the power minus 5 meter. The distances from 10 to the power minus 4 meter to 10 to the power minus 5 meter can be used by the help of screw gauge or spherometer. Spherometer, these all instruments you will observe in your physics lab, and there are experiments based on these instruments also in your physics lab. So, spherometer, these are used for measuring the distance up to 10 to the power minus 5 meter. Means by the help of direct methods for the measurement of length, the distance between 10 to the power minus 3 meter to 10 to the 1 millimeter to 1 centimeter by the help of meter scale. Vernier calipers can measure the distance between 10 to the power minus 3 meter to 10 to the power minus 4 meter, and the screw gauge or spherometer can be used to measure the distance between 10 to the power minus 4 meter to 10 to the power minus 5 meter. Now we will come across the indirect methods for the measurement of length. Indirect method, these are the direct methods. Now what are the indirect methods for the measurement of length? Indirect methods for the measurement of length. Indirect methods. Indirect methods. Indirect method are that method in which direct application of instrument is not required to measure the physical quantity. Means that physical quantities cannot be measured by the help of direct methods, or instruments are not designed for the measurement of such type of length. In that case, we use indirect methods, that is large distances such as distance of planet from Earth, or size of a planet. Distance of planet from the Earth or size of the planet. This is one thing which can't be measured by the help of any instrument. So indirect method can be used for the measurement of this. And the distance of the planet and its size can be measured by the help of a method that is called parallax method. So first note it down. Distance of planet and its size, that is called as parallax method. Parallax method. P-A-R-A-L-L-A-X, parallax, M-E-T-H-O-D method. So this thing can be measured by the parallax method. Now we will understand what is the meaning of parallax. What is the meaning of parallax? What is the meaning of parallax? Parallax means to say that the apparent shift of the position of the object, or difference in the position of the object in different backgrounds when viewed when the object is viewed by closing subsequently left eye and right eye. For this, I am taking an example. Suppose a pencil is kept here. Suppose a pencil is kept here, and this pencil, and you are standing just in front of the pencil and observing this pencil or marker by closing your left eye and right eye. By closing your left eye and right eye, then by closing your left eye, the background of the pencil is quite changed, and closing your right eye, the background of the pencil get changed. So that are the two observatories from where this pencil is observed, and that method, the distances from left eye or right eye, both the observatories making an angle theta, that angle is called as parallaxical angle or parallax angle, and the separation between these two observatories or these two positions A and B can be measured. That phenomena is called as parallax, and the distance between these two observatories, suppose this is pencil, and from one observatory A you are making this, and the second observatory B you are making this, and this is the separation between these two observatories, and it is making an angle theta, and the separation or distance of point O from both the observatories is D. This is the separation and this is the distance B. So this phenomena is called as parallax, and the measurement of this distance, is called as, the angle theta is called as parallaxical angle. Theta is called parallaxic angle, and B is called as basis. So as you know that for very small separation between 2 points A and B, the arc so formed between A and B, suppose this is a center and a circle, by assuming D as the radius, a circle is drawn, and if the separation is very much small, then the distance between A and B can be considered as the basis B, and it is a straight line. So you are knowing that the parallax angle theta, that is equal to arc upon radius. So this arc is what? This arc is B, and the radius is D. So by knowing the value of basis B, and measuring the angle theta, and knowing the value of B, by measuring theta in radian, and knowing the value of B, that is the basis, separation. This is called as basis or separation. If you are knowing the two things, then you can calculate the separation between the observatories, the two observatories and the object. You can calculate the separation between A and B if the separation between A and B is known to you, and if you are measuring the angle theta in radian, that is parallax angle or parallaxic angle, then the separation between these two you can calculate easily, and that is the separation between. So this method is useful. In calculating the distance. This method is useful in calculating the distance between the Earth and any given planet. And it is also useful in calculating the diameter of a given planet. If you had to say that what is the size of the given planet, the size of that given planet also you can calculate. So both the things can be calculated. Both these things can be calculated by the help of the method parallax method. Parallax method, by the help of parallax method you can calculate these things. So in the next class, in the next lecture, we will calculate the distance of the planet from the earth. After that we will calculate the size of the planet. Then we will discuss two other indirect methods, that is Kepler method and Copernicus method, and after that triangulation method, and then laser method and other methods which are the indirect methods for the measurement of distance we will discuss. So that's all for today, students. Thank you. Have a good day.